Okay.
So we're just going to start the quiz.
Sorry?
Start the quiz and start working.
Yeah.
Did you guys have a chance to watch his presentation? I just got home and I haven't had a chance to.
No, I wasn't able to watch it.
Yet.
Oh, it's not?
No.
Get it in my email yet.
I'm sorry I'm eating in front of you. I haven't had a chance to eat all day.
Oh, you're fine.
Go for it. So we might as well start with number 2. In an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level, high school, undergraduate degree, master degree, doctorate degree of people who manage successful startup companies in the United States and Korea. You want to determine if the educational level of managers of successful startup companies are independent of the country they're from, United States and Korea. Which hypothesis test would be most appropriate?
Okay, I don't remember this one from the exam review. I guess they're throwing in some other stuff.
Well,
So it's one data set.
But it's different country.
Yeah,
compared educational levels, educational
Degree.
level, high school, undergraduate degree, master's degree, doctoral degree.
Oh, I think this is
Is that ANOVA?
T squared.
You have United States and Korea at their degree, high school, undergraduate, master's, or doctorate of people who manage successful startup companies.
You want to determine if educational level of managers of successful startup companies is independent of the country they are from.
I believe it's T squared. Let me open my. So we've got columns and rows for the T-square because we need to put in startup businesses in the United States and Korea. So we would need 2 columns,
right?
And then the names of the companies, right? And then maybe what kind of degree they let me see. The kind of degree they had and United States and Korea.
Yeah.
Okay, so let's first decide, is it categorical or quantitative?
Categorical.
Categorical.
Okay. Then after categorical, then we look at 1 sample, 2 samples, and row X column table.
So do you think it's cheaper? Do you think it's paired?
No. Was paired independent or dependent? Because I thought paired.
Well, they're comparing the United States and Korea. That's who they're comparing.
Oh, it says in the startup company is independent of the country they're from.
Okay.
So it's either 1 proportion, 2 proportions, or chi.
Because those are the only categorical tests.
Right. We only have 3 categorical tests. And since it's not just 1 proportion, has,
I think she's right that it's chai, because there are columns and rows. It's going to be just like when you're filling out.
yep.
I'll pull back up that. I pulled up all of those.
How many different ones is it again? High school.
Because you could put high school, undergraduate, master degree, doctoral degree, and then you would have
Okay, so
whatever
like
those
this?
numbers are.
So it's not ANOVA because that's
Like that.
that's variables. It doesn't have rows and columns.
You see like that picture? Korea, US,
Yes,
and then there's 4 different areas.
right.
Yep.
And so that would make it the chai.
Or chi.
Or chi.
Oh, he just spit on the floor.
You get a rag and you clean it up right now.
Okay.
Okay, so then, you ready for 3?
Up. Yep. The human resource manager reported data from a recent involuntary reduction in force at their company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40-year-olds or younger and 40 years older. They also reported a number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be appropriate?
Okay, let's start with quantitative or categorical.
That'd be quantitative.
Quantitative.
Okay, so we have quantitative, and then we need 1 sample, 2 samples, or 3 plus.
Well, you got the under 40, over 40, and terminated, right?
Wait,
Well, they reported it in
I have 2 groups.
It says, yeah, the company reported the number of employees in 2 groups, 40 years old and younger and over 40 years old. They also reported the number of employees in each group, in each group who were terminated. So there were 2 groups, and within the group, there were
The ones that were
breakdowns. So then they had a breakdown within the group.
right.
That's almost at N and X.
Okay, I lost you guys for a minute.
They're just trying to do what I do. I get lost all the time.
Okay, so where are we? Sorry.
3.
We're on 3. What did you decide for the number 2? The chi?
Yes.
Yes, Kai.
Okay. 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 You say tomato, I say tomato.
Well, I said
Say
chi
chi,
earlier.
I Okay.
Okay, so we're quantitative. We have 2 groups.
And then we have 2 breakdowns from that. That's why
They
I'm wondering if
also-
it would be a categorical because the X over N, X is the number we have, and there's N, which is the full amount. So that's why I was wondering if it could be the 2 samples because of the P equals X over N. Yeah, P hat equals X over N. And so that's what I was wondering because it's talking about, they have 2 groups, but within the 2 groups, so they gave you, we have this many 40 and under, and this
Right.
many 40 older. But then within the 2 groups, they also said, okay, and these are the ones that are terminated. How many that
So
have
you
been
have
terminated?
X1 and X2, like X1 you know what, how I had X1 and N1 and X1 and X2.
Mhm.
So what was that? X1, which Excel?
The two sample proportion one.
So since we don't have a sigma,
Yeah, 2 sample Z test proportion.
Yes.
but since we don't have a sigma, what did you guys think?
Test the two proportions.
Okay.
Well, a
Because it's
proportion
supposed-
then would be categorical though. And we
Right.
decided this was quantitative.
See, I'm not seeing. So we're saying that they're dependent or independent?
They're independent.
Because we're trying to see if there's discrimination.
So you're
Right, but there's
not
4
fired,
years and older.
fired, right?
How about a 2 sample t-test? Oh, that's not a choice. We get a 1 sample, 1 sample, or a paired.
Paired would be the two sample, the two.
Variable 1, variable 2, and then the difference between the two.
And it'd be, so in between, in the two groups, you'd have 40-year-old fired, not fired, over 40, younger than 40, fired, not fired. So would that make it categorical?
Well, that's why I was wondering if that's why it would be categorical.
Because based on categorical, it would fit as
The two sample,
the 2 sample.
two proportions.
Yeah, and that it lays out. Whoa, I just lost my eraser and all my lead.
But that's the only reason that I was asking is just because it had in there, it gave the number of employees in the two groups, but then, so I gave you an overall number, and then it gave you a number of who was terminated, which could be the X over N.
Yeah,
And
no, that
just
makes sense.
These are easier.
Yeah.
Because looking at, I mean,
But it
it's going
wants
to
to know
either
if
be,
age was a discriminating factor. So is age, to me, is age categorical or quantitative? And that was on our last test, the one we just took.
I'm back.
which would be proportion then. Because the only other one that has like the means of 1 and the mean of 2 is the paired sample t-test. So it's just determining which is it.
It
Categorical or
doesn't say
quantitative.
anything about, the paired samples have to be equal, right? There has to be equal amount of, it doesn't say anything about each sample being the same amount of employees.
Right, and it doesn't have an equal amount. That's why I was wondering if it would be the portions, the two proportion, because it doesn't have an equal.
I think that makes the most sense.
I'm just trying to.
I had put G. I had originally said that it was a test of 2 proportions.
Sorry, guys. I don't know what's going on. For 3, did you decide to test the 2 proportions?
That's what we're talking
For
about.
3, that's what we're doing, yeah.
A test
Okay.
of 2 proportions.
What are the requirements for a t-test? Don't you have to have a sigma and a mean?
No. Let's see,
You don't?
t-test. You either If it's a known sigma, then it's a 1 sample Z. If it's an unknown sigma, it's a 1 sample T. Dependent samples is T. And independent samples, that's a 2, is still T.
Okay, there's only one thing that would fit then. Well, it's either ANOVA or test of 2 proportions. Let's see what the ANOVA looks like.
Well, because ANOVA, you need more than what we have.
Oh, yeah, you need multiple.
More samples than what we have.
Okay, a survey conducted a group of state lotteries, random.
Would it be a chai?
Mm.
I think you're right. I think it's a 2, test of 2 proportions.
Yeah, I think that's the one that makes
For 4 or 3?
For 3.
3.
Oh, yeah, I think it's a test of 2 proportions.
Because chi also has like the null being independent and the alternate being dependent. And so we're not really looking at that. Okay, ready for 4?
Yeah.
The survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate? So we know it's going to be either a test 1 proportion, test 2 proportion, or chi test. And I think it's not a chi test. It's going to be a 1 or a 2.
I was going to say, I think 1, but.
Yeah, I think it's test of 1 proportion.
And it's a test of 1 proportion because you have 1 random sample.
Yeah. Random sample of 2,106 adults.
And you're just trying to figure out that percentage. Because that's that politic one. That's what I was trying to look at the chapters. There's a politics.
Oh, yeah.
I'm just trying to differentiate between the two, so when I see a question, I can say, oh, this is a random sample of, 1 random sample. We're not comparing 1 and 2, I guess.
Okay, so lesson 16, it has the political election out. If it's dependent upon each other of which party you vote for, or which person you vote for, depending on your party.
Mm-hmm.
It's in lesson 16, you said?
Yes. I mean, it's just like, and it also has tossing a coin. It's talking about the percent of times that you tossed it.
Was Kira back in bed? She screamed when you left.
Yeah, she's fine. She wanted to move beds. She's been sleeping on the lower bed, but she doesn't sleep well there. So I go in there, she's burning up hot because she wants the big covers. So she has to go to the other bed where she sleeps just fine.
Okay.
Anybody have anything different? We lost Esther again.
Oh, we did. I just think that it is a test of one proportion, F.
Esther said she had to reboot.
Yeah.
Although, do you agree that one test?
Yeah, because I'm not finding anything that would so.
So 5, a student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise first and the other turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took to open each of the locks was recorded. They want to determine if one of the locks is easier to open, which hypothesis test would be most appropriate.
Oh, this is that one where we're like, it's like weight loss, or a husband and wife, where you have the two.
Yeah.
Like X is your test and A and B. So A would be the first time you did it, B would be the second time, except for this would be.
Right, so it'd be. Would it be the paired, do we have a paired test?
Paired samples t-test. Because it is the numbers, it is quantitative. You're looking for numbers, you're looking for how many times. Because I don't think are they independent or paired?
I think they're independent because you need to look at, the first time you did it isn't based on how the second time you did it. The first time you did it is one set. The second time you did it is another, and what's the difference?
Well, it's 2 different combination locks.
Right.
So they're independent.
Yeah. I see.
So that's why they're independent, because one is not based upon the other.
Yeah,
Easy.
okay.
So if I'm looking at so what did I put? I gotta move my screen. So you don't think it's a paired sample?
No, because they don't rely on each other.
Oh, that's true, but for the independent sample, are you using the same paired sample test in Excel? Or are you using...
You're going to be using let me get it here.
Because the paired test is the only one that has like variable 1, variable 2, and then the difference.
Okay, do we have the...
Oops. Oh my gosh. Go.
Trying to find the right one.
And that's why I was thinking paired sample t-test, because I didn't know if they were looking for the difference between the two.
Trying to find out which one was easier.
Okay.
So
But
we
one
have the
isn't
option
dependent
of one sample, we have a paired sample, and we have a two sample. Sample t-test, which is the independent, because you
Okay.
can put any number of variables. You got variable 1 and variable 2, which have different numbers. And like
right?
variable 1, the one I'm looking at has 4 numbers, the other one has 5.
Yeah, no, that makes sense.
And so because one is not based on the other, they're not, it's not like they're taking the same test twice. They're having one
Right.
combination and then another combination lock. There's two different
Gotcha.
locks.
Okay. Yep.
And so
So
that's why
the
I
number are
think
you guys
independent
on?
sample t-test, we're gonna use the 2 sample
yes.
t-test.
Esther, you're back.
Yeah, I don't know what happened. I had to reboot my whole computer.
Oh, geez.
What number are you guys on?
We just finished 5.
We're cruising right
I
along.
have to log back in. Let me see. I'm going super slow. I don't know what's going on. Oh.
Ugh. Confidence interval.
Okay, so 3 is a one test of one proportion.
Correct.
Wait, what
I
you
thought it
have
was
for
test
3?
of 2 proportions.
I thought.
Test of 2 proportions.
I
Okay. It
On
didn't
the
say.
first one,
No. On 3.
on number 3, I put a test of 1 proportion.
There were 2 groups, right?
No, there was a survey conducted, a random sample of 2,406 adults. So there was 1 sample.
Wait,
A
we're looking
total
at
of
number
2.
3.
Number 3?
Oh, number 3, sorry. Whoa. A test of 2 proportions. Sorry. Number 4 was a test of 1 proportion.
Yes.
Number 5 is independent sample.
Let's see. Student compared. Okay. And now I can't find my math. There it is. My computer, it's super slow. Have you guys seen that commercial of the sloth that's paying Pictionary?
Oh, yeah. Pictionary's drawing the line. I just saw that. I laughed so hard. It made
Oh
me
my
think of, what was that cartoon, that movie that came out with the sloth at the DMV?
That was Zootopia.
Oh, it was so funny. I laughed so hard at that.
So funny. Okay, so 5 was, let's see, student projected compared effect of 2 different combination locks. 25 students. Is that a 1 sample Z test or T test? T test.
Which number?
5?
Which number?
Number 5.
Independent sample t-test.
Oh,
Because
okay.
the 2 samples do not depend on each other.
okay. Okay. So bank employees, 2 appraisals. Bank employees, the bank employs 2 appraisers. when approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure that this is the case, the bank evaluates 6 properties, so that's the sample, that both appraisers have recently valued, which confidence interval would be most appropriate for this study. I said pair sample on this, pair sample T confidence interval.
Yeah.
Yeah. I agree.
Okay. Okay, then number 7. In a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting that they are satisfied or very satisfied with their career path was recorded. The same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is significant. Which CI would you most appropriate for this? So psychology majors and accounting majors, I thought this was a confidence interval for 2 proportions. What do you guys think?
Okay, give you a reason why. Sorry, I like.
Because they want to know how confident are you that psychology majors and accounting majors are satisfied or very satisfied. And you've got 2 proportions here. You got psychology and accounting.
And it says the percentage of psychologist majors reporting, so it's a percentage, and a percentage is either going to be a proportion, it has to be a proportion, right?
Yeah.
Yeah.
Because it's a percentage, so it gives us 1 proportion or a 2 proportion. And seeing as how there's 2 appraisers.
Well, look at the options though.
Or wrong one, sorry, satisfied, not satisfied.
It's not a 1 sample, it's not paired.
Nope.
I don't think it's a T confidence interval. I don't know. Let's take a look at that.
I think it's either going to be the independent sample T confidence interval or the 2 proportion.
I think it's a 2 proportion.
I think it's a 2 proportion because of that whole, is it a portion or percentage?
Percentage.
And because it's a percentage, it's going to be.
So wouldn't that make it categorical?
Yes.
Yeah. Not saying on a scale of 1 to 10, satisfaction. It's either yes or no. Sorry, Esther, I'm only asking to define so, because it helps all of us with our thinking process.
It's helping me a lot because as we're talking through this, I'm making notes on how I know why that is what it is. Because that's my biggest problem. So I can say this is a test of 2 proportions because because it was a percentage, so it's going to make it, either proportion 1 or 2, but I can eliminate why I chose that. So yeah. I love talking about this.
And that's why it helps me to okay, that helps me remember, okay, drawing back on.
Right.
And I know it sounds terrible. Sometimes I just don't know why. I can't think of everything that we learned. I just look at it and I go, okay, well, and then I look at the spreadsheet and I go, well, it looks like it fits there based on what we've done before. I don't like these questions.
I don't know.
Oh, me either, by any means.
What did you guys decide on that?
On which one?
The last one, right? Confidence interval for 2 proportions.
Okay. That's what I thought. Okay, double stuff.
I don't know why I think I've seen this question before.
No, we have.
Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if it's true. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each. You need to construct a confidence interval to estimate the true mean. So that means it's going to be quantitative.
Yep.
You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount of regular Oreos. Which confidence interval?
So
I
is it
thought
gonna
this was
be D
a
or
one
T?
sample T confidence interval because it says A sample of 55 double stuff.
Yeah, we know it's
And-
one sample, but is it Z or T? Because T means sigma is unknown,
Sigma is
and Z
unknown.
means we know.
Yeah, because we don't know what the standard deviation is. We would make it a Z. Wait, let me see.
But personally, I would just have eaten them. So
As long as they were vanilla. I like the vanilla ones. It's an ongoing debate with me and my husband. So if we know sigma, it would be a Z confidence interval. So I think it's a T confidence interval.
right, because it doesn't tell us. It just talks about true meaning. It doesn't talk about sigma.
It doesn't have a sigma, yeah.
Everybody okay with that?
Yep.
That's what I think, yeah.
Which of the following best defines the notion of a significance level of a hypothesis test?
Okay, this one I did.
So I could remember on the test that we just took, and I know this question was there, if this was the probability of observing a sample statistic more extreme, or if that was the next question, what the p-value is. And I think that's what the p-value is.
Yeah, that's
So
p-value.
I think I'm confusing the two. And so,
Would it be C? Would it be C?
Tell me again what a type 1 error is. I forgot.
That's what I'm trying to find.
oh, I
error.
have it written
The
with the right book.
type 1 error is committed when we reject a null hypothesis that is true.
That's true.
But look at the probability of rejecting HO, whether it's true or not.
So the p-value is based on alpha, right? And we reject the p-value. We fail to reject if the p-value is greater than alpha, which is typically 0.05. Reject it if it's smaller. Help me with that. Am I right on that?
Like we have a greater chance of, I'm trying to remember writing it, greater chance of committing a type 1 error.
It's in chapter 7. I know that because I have it in my chapter 7 notes. So let me.
We fail to reject if the p-value is greater than alpha, the confidence interval.
Okay, we gotta remember the question.
Which is,
Best defines the notion of the significance level of a hypothesis test.
oh,
So is it
Okay.
3, the probability of rejecting null, whether it's true or not?
That's what I was wondering. Because that is what we're trying to do. That is what it is showing.
Yeah,
Is if we reject the null or keep the null.
yeah.
Sorry, I'm trying to go back to the lesson 7 just to. verify that. But
Best defined information. I don't.
my computer is taking forever.
It's because it's tired.
Like me. We like have half our staff out this week and it was so busy. It was crazy. Oh, just load, will you? Bum, 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 bum.
Let's see, it says the level of significance A must be chosen prior to collecting the data. This is our standard for determining if the null hypothesis should be rejected. It is important that the personal bias of the researcher is not imposed on the data. If we wanted to reject the null hypothesis, we would compute the p-value and then unscrupulously choose the A level.
I don't think it's the second one, the probability of rejecting HO, whether it's, I've never seen it worded that way before.
Right.
That wording before?
It's just instead of saying null and not for it or against it, because it's saying what is the notion. So what we need to go with, what is the significance level of a hypothesis test? How is it defined?
It's defined by the alpha.
But why is that important?
No, that's chapter
I don't know.
9. I
From
don't
what
know
you
why I
said,
thought it was 7. It was chapter 9.
I think it's the type 1 error, like you said.
Okay,
So
so
notion.
it says the A value, if the A value, and then in the whatever those are called, the probability of committing a type 1 error is very small. The probability of committing a type 2 error will be very large. So it's the probability of committing a type 1 error.
That's what the significance level. Because a notion is the concept or a belief about something. So what is the
When we
belief?
test the hypothesis, we assume the null hypothesis is true because of this requirement that whenever we use mu in a calculation, we can see, I'm not finding that either. We gather evidence against the requirement of the null hypothesis is true. We get enough evidence against the null hypothesis, we reject it.
Well, this is just asking what is our belief that the significance level of a hypothesis test is for.
What's a type 2 error?
A type 2 error, okay, so
Okay, wait, right here it says a level, wait, don't move it.
Oh,
Where'd it go? A level of significance at 0.05 seems to strike a good balance between the probabilities of committing a type 1 versus a type 2 error. However, there may be instances where it will be important to choose a different value for A. The important thing is to choose A before you collect your data.
yeah, and right up here is if the A value, the probability of committing a type 1 error is very small, the probability of committing a type 2 error will be very large. So I think it's the probability of committing a type 1 error is the answer to that problem.
So it says if the A value is very small, Well, that means that you have less chance of committing a type 1 error than you do a type 2 error, right? Because it's a greater chance of committing a type 2 error. Maybe it's type 2.
But I don't understand what's wrong with 3, the probability of rejecting HO, whether it's true or not, because that's what's going to happen. We're either going to reject or fail to reject HO, regardless of whether it's correct or incorrect. If we fail to reject HO and it's not true, we do a type 1. If we reject, you put back up your little thing about failing to reject and eject the little chart of not HO true, HO false. That's on low screen here.
Let's
Yeah.
see. Yeah, maybe
Because
it's type
that's
the
why-
probability of rejecting HO, regardless of whether it's true or false, that's what's in this table, regardless if it's true or false.
That's what
We're
you're
either
looking
going to
for.
commit a type 1 or a type 2 error.
But that's why I thought it could be the third one, just because that's what you're trying to decide, if it's true or if it's false.
Right.
And the level of significance gives you the true or false.
Because the level of significance, the notion of the significance level is going to tell us whether we fail it or we reject it. Because that's what the significant level does, right? The 0.95 or 0.05 or whatever, 0.05, if that's your
Correct.
level of significance, it's going to tell you you either accept it or reject it.
Like the significance level helps you determine if you're going to keep it or not.
I think we go with type 1.
I'm just going to go with the probability. I'm going to go with C, probability of rejecting HO, whether it's true or not.
Okay.
We'll see.
Okay, so which one of the following best defines the notion of the p-value of a hypothesis?
It's 3.
Yeah, it's 3.
Okay. And then suppose you create a 95% confidence interval for the mean and put 10, 20. Oh, and get 10, 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? Okay, I missed this one on one of the quizzes, and I think it's the second one. 95% of all 95% of confidence intervals actually contain the true mean. I think it's that one based on what he said in one of his videos.
You know, and that's what I
could be wrong, but that's what I thought it was.
Okay, cool.
That's what I'm looking at with 4 for the true mean.
think because this one has a range, I don't know. Because I know what you're saying, Esther, about the 95% of 95% confidence that actually contains the true mean.
Yeah.
I remember that question. And in fact, it was just on our last quiz as well. I wish I would have printed out the quiz.
I know.
I actually have it. Which one was it? Was it the homework or the group?
It was the homework quiz.
And it was
It had a
19.
question just like that on the homework quiz.
Let me pull it up. Oh no. When I print these to PDF, it doesn't tell me the right answer.
Oh, that's awful.
I know,
Okay, I'm scrolling through.
except
This
for the
was,
ones that I had to actually put an answer in.
how do I go back and look at it?
Oh, that's terrible. You can click on the little, well, no, bueno.
I guess I can just go to last week and click on quiz. On the 19 homework. Oh, here we go. Homework, quiz, 19. Homework, quiz, 19. Oh, well, that didn't work.
I didn't actually see that question on there. I couldn't see answers, but I didn't see that question either.
Yeah. I clicked the wrong button. I wanted to. Oh, can I see submissions? Ugh. I hate when I click the wrong thing because it takes forever to get anywhere. The last thing I want to do is have to keep.
So the reason I thought it was 4 is because in the reading somewhere, I'm not sure where it was because I just wrote down the note, but it said the confidence interval, and it said we are 95% confident the mean of the difference is between number and number. So I thought that because it says between the number and the number, and so there's a 95%.
Why is the true mean? That, yeah, they're saying we're not looking for a sample mean. We're saying somewhere between 10 and 20 is the true mean.
Yeah, that's why I picked 4.
And I think if they didn't give us work with, then number 2 would be true.
Yeah.
So you think it's number 3?
No, 4.
I mean 4?
Yeah.
Yeah.
Oh, it wasn't on that test. I don't know which test I was looking at. Was it 18?
There was one on the quiz.
It must have been 18 instead of.
It was as part of his semester project at BYU Idaho Introductory Statistics Student calculate 95% confidence interval for the true percentage of BYU Idaho students who are from Latin America. What does the phrase 95% confidence mean?
See, and I think that's different. That's where it says 95% of 95%. And that's what I was trying to differentiate. Between the two.
Okay.
All right, on to number, are we good?
Yep.
We're going on to 12.
So
You
this
take
is
a break.
this is just asking you what the mean of the distribution of the sample proportion is, which is P, right? Isn't it the last one?
Yeah, that's what I have.
That's what I put.
What's the standard deviation of the distribution of the sample proportion?
Yeah, the mean of the distribution.
Wait,
I think it's 0.30.
you think you use it twice?
Mm-hmm. I
The
think
mean
that's what they're
distribution of the sample for 12. Assume an unknown population portion or percentage of people in a town who invested in the stock market is P equals 30.
What's the standard deviation? So is it that point, is it that 95%?
Well, it's asking for the mean of the distribution of the sample proportion.
Wait, which number are you on?
Right.
12?
Oh,
Are we still on 12?
30, right?
Yeah, I thought it was
0.30.
0.30. Oh, so now we're on 13 then?
Yes.
Right.
Oh, let me see. Distribution of the sample proportions. Oh, hang on. Maybe I did this wrong. Distribution of sample proportions. Okay, standard deviation for the distribution. So this one I thought was 0.046 because you have 0.30, right? Times
Right.
1 minus 0.30 divided by 100 square, all of that squared, equals 0.0458 equals 0.46.
So you're saying that the formula for this is P times 1 minus P divided by the square root of N.
Well, divided by 100 and then you square root that entire answer. And I came up with,
Divided by N squared?
yeah, you square the whole thing.
So it's P times 1 minus P over N squared.
No,
And then the
it's
whole in parentheses and then squared,
P times
right?
1 minus P
Right.
divided by 100 square. Divided by 100 and square the whole thing.
So you put N divided by 100, and then
Yes.
in parentheses, then you have the squared at the top. So whatever the answer is times squared.
Oh, I thought we
Yes.
got that with the, what is that one?
That it?
The what?
That one?
Yes. Yep. That's the one I used.
You know what? I wrote squared, not square root. I put that back up for a second, will you?
Yes,
Well,
ma'am.
because I wrote.
Square root.
So-
And I'm sorry, I did say squared. I meant square root of the whole thing.
Okay, yeah, because that's what. Okay, I'm good.
So I think it's B, 0.046. Did you guys get that?
Yeah, that's what I
Okay, a
got.
second.
You're only doing 3 numbers, right?
Yeah. 2 of them are P. So it's P times 1 minus P. Divide that by 100, and it's the square root of that.
Yep.
Yeah, 0.458, 0.458.
Yeah, 0.046.
Yeah, at the top it says to do the 3.
Right.
Right.
Okay.
Okay, so what is the proportion of your random sample of 100 adults will have a sample proportion of less than 0.25? I thought this was A. Oh, I thought this was 0.138.
Okay, and what equation did you use?
I use Z equals 0.25 minus 0.3 divided by 0.046, which was the standard deviation, equals, let me see, minus 1.0869. I did this all on the computer. So it's 0.30 plus 1.0869 equals 1.3869.
Wait, did you say you use plus?
Yes.
Can you repeat your formula on that?
Let me see. Hang on a second. Yeah, that's not right. How did I get that? I didn't write this down because I've been losing my papers.
Because
Okay,
usually
so
it's
what I did was 30 plus 1.0869 equals 1.3869.
For some reason, what you're
And
saying, my head is going wah wah wah. Can you repeat it one more time? You
yeah,
took
so Z equals 0.25
0.25,
because that's the sample proportion that's
right?
less than 0.25 minus 0.3,
Right,
which is the P,
right.
divided by the standard deviation, which is 0.046,
Right.
equals,
I didn't get that as my equal.
let me see what I did.
0.025 minus 0.3
Yeah, I don't know why.
equals a
30. I have
negative 0.05 divided
0.25
by 0.046 equals negative 1086.
9.
well 7.
Mm-hmm.
Equals negative 1087.
Well, what
Then
do you
how
have?
did I get?
But that's
How
not
did I
any
get
of our answers.
I didn't
No,
get this one. I wasn't sure how to calculate it.
I have 30 for the P plus the 25 minus 0.3 divided by standard deviation. So I have 30 plus that number equals 1.3869.
So you
And I don't know
added it,
where
you didn't subtract it?
I added it. So 0.25 minus 0.3 divided by 0.046 plus 0.30. I wish I'd have written this down. I'm sorry, guys.
Yeah, because I can't make it equal that. anybody else making that?
Yeah, 0.30 plus 1.0869, which came from the 0.25 minus 0.3 divided by 0.046.
So I got 0.25 minus 0.03 is negative 0.05.
Divided by the standard deviation, which is
0.046.
Mhm.
Oh, 45, yeah, because 0.46.
I'm still not getting 0.1838.
Me either.
Where did you find that equation?
That formula?
Yes.
That's a good question. I did not write that down.
Yeah, because I'm not getting,
Anyway, that's what I got, and I got that number, so I thought that must have been the right one.
Because it's obviously a one proportion
Mm-hmm.
or one.
Oh, let me see. Maybe I used the Excel.
well, do we have enough information to put it in Excel, I guess would be the question.
Let's see.
So if we pick a,
So we have 100.
This is the stuff I'm finding on this sample proportion. It's in chapter 16. It's that coin thing.
Oh, the chances?
Now, it talks about sampling distribution of the sample proportion. Is that what we're looking for right now?
Yeah, sample proportion. Oh, maybe I put this in the probability applet.
So I can see you taking the z-score and putting it in the normal probability applet.
Yeah,
And then
I
getting
think
the
that's
area.
what I did. Let me do that. So if I take 1.0869, it equals 0.1385. That's what I did.
not that I already saw that.
So I took the z-score and I put it in the applet, which comes out to 0.1385. So z equals value minus mean divided by
Right.
standard deviation, right? Okay, so we got the z-score, and all we need to do is put it in the applet, which gives you
So the z-score was 1.0.
869.
It's basically 7.
So 1.087.
So it's going to be the left side only.
Yep.
Oh, dang it. It's 1.38. There we go.
So it's
Yep.
1.39.
Yeah,
Right.
but there is no 1. Oh, okay, 1.39. Okay.
I wanted to write down that formula, that z formula again. Z equals P minus,
No.
Value minus the mean divided by standard deviation.
Right.
that was chapter 16,
Yeah.
just so I can make notes, I'll go back. Okay, 1 point, how am I at the top? Oh, because I went to get the,
And for the next one, we're going to need the 2 proportion z-test Excel spreadsheet. And I got X1 as being 61. N1 is 1563. X2 is 15. And N2 is 579.
I gotta get them typed in.
And so I got D for the answer.
You're so fast.
Yeah.
I know. I didn't even get it typed in yet.
Which
You
test
said a
did you use?
2-sample t-test?
2 sample z-test, 2 proportion z-test is what I use.
Z-test?
Yeah. Because you're going to need the P, remember the P1 minus the P2? That's the only place that I've seen that. .95% confidence interval.
Okay, so for
I'm gonna pull that-
N, you put the 1563.
N1 is 1563.
N2 is the same.
N2 is 579.
Oh, okay, there it is. So do we want to put 579 on top?
I put 579 on the bottom for N2. Oh, but you know what? When I do that, if I actually work it out by hand, I get D, but looking at this, I get E.
Doesn't matter.
Because if you do 61 divided by 1563, you get 0.039, which is 0.04. But it's saying in the spreadsheet, it's saying 0.03. 0.003. So what am I doing wrong?
Okay, so we had a control group of 579.
Yes.
Yep.
61 experienced dizziness. And of 579 subjects in the control group, 15 experienced dizziness. What did you put for X1 and X2?
X1 I put 61, X2 I put 15.
And N1 you put 1563?
Yeah.
And N2 you put 579?
Yep. And it's a 95% confidence interval.
I got that, okay. Minus.
Okay, how do we do the margin of error again?
You subtract the confidence level P1 from P2.
The highest from the negative, 0.29 minus negative 0.003, and then divide by 2, right?
Yeah, but it's not asking us for that, though. It's asking us for
the margin of error.
error.
Oh, it wants just what it is, 0.00.
What number are we doing? Let me see.
15.
Oh. Okay,
Yeah.
remember this is the one that I worked out before and I texted everybody?
What was 14?
So it's P hat minus P hat 1 minus P hat 2.
2, yeah. Yep.
Why is my...
So it's 0.039 minus 0.026, which is 0.013, right?
Yep.
I am confused. Because my questions are no longer following this.
This was the one that we didn't get in our last quiz, and this is actually the same question, I think, because that's what it came out to.
It was the P, you have to do the P hats because of the,
So what'd you put for 14?
For 14,
Yeah.
14, I had
Oh, maybe.
0.139. Because we used the normal probability applet, it was 0.1385. We have to narrow it to 3.
Right, I got 1.138. I guess I was looking at questions 4 through 18 on my study guide, and all of a sudden it's not matching question 15 on what we're doing here. That's what it threw me for a loop. Because I wasn't able to check my answer with what I had, so, do you know what I'm saying? If you look at question 15 in our review, it's not the same as question 15 that we're doing right now.
But we have to take p hat 1 minus p hat 2.
Right, so that's what I need to do. P hat 1
0.013. Is that what you guys are getting?
Yeah.
is 0.013.
And so the lower bound on that is, let's see, is minus 0.003.
Yep.
And the upper bound is 0.029.
yeah.
Okay, so perform a hypothesis test. Perform a hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different from the proportion of control group subjects who do. Of 0.05. What are the appropriate null and alternative hypotheses? I put B less than, equal to, and less than, or greater than rather, sorry.
Oh, I think we had this, so I think I got this wrong on the last one for some reason. So it's just asking if the proportion of spare groups is different than the proportion of the control group. So it's equal or not equal, right?
Well, the HO will be equal, the null is equal.
Right, and the alternative is not equal.
It doesn't have not other, wait.
I got greater than. Let me see why.
Because it just says, let me read again. Use the significance level of 5. What is the appropriate? No. Let me go back up. Perform a hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different than the proportion of control group subjects who do. So it's not saying it's higher, it's not saying it's lower, it's just saying is it different?
So one definition he gave for proportions is the null is independent and the alternate is dependent.
So what do you think it is?
The first one.
That's what I thought it was.
What is that for 19?
The value of the test statistic, that would be Z, right? 1.458.
Yeah.
But I think something's wrong because the p-value of this test, our p-value does not match any of the p-values. Oh, because it's greater or equal. It's not, you got to change your type of test, don't you?
I did greater than, let's see.
It's equal or not equal, and then it's answer D, 0.145. I think.
1458, yeah. The test statistic doesn't change regardless of whether it's equal to
Right, it's just
greater
the value that changed.
Right.
than. But for the p-value, I got 0.072.
That's because you did greater than.
That's because you input 1.458 in the applet. And I think it's left tailed on this. I did do it's greater than.
Well, I would say right tail just because it's positive. You don't
Yeah.
have a negative Z value.
Oh, that's right. Okay.
I just don't understand why you picked greater than. Because it's just asking.
Well, why would it be a two-tailed test though?
Because it's asking if there's a difference. It doesn't matter if it's greater or less. It's just asking, is there a difference? Perform the hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different than that of the proportion of control group subjects.
Yeah, they're just trying to find out if it causes, or doesn't work. What do you think?
I have no idea. I'm sorry. I'm not understanding what the hypothesis test has to do with the determining the null and alternative.
So for the proportion, he kept saying in the class he had last week that it's independent and dependent.
So what does that have to do with greater, less than, or equal to?
So that would be it either is or it is not for the proportions. And since we're doing the proportion one, because it's not asking greater than or less than, it's asking is it or isn't it? There's a greater than.
If we read 21, maybe that'll help shed some light, maybe. Because it's asking us what we're going to do. It says, is there significant evidence to conclude that the true proportion of people who experience dizziness while taking Acuprel is different than the true proportion of people who experience dizziness while not taking Acuprel?
So I answered no. I failed to accept the null hypothesis because we don't have sufficient evidence that P1 is greater than or equal to P2. Where did I see that go from? Greater than or equal to. That was the last lesson.
But if our p-value is 0.145,
It's greater than, we failed to reject the null.
Mm-hmm.
So it's the last
A.
one.
No, the null is HA. Right?
no, the null is
It
HO.
is the alternative.
So I failed to reject the alternative because because 0.07 is greater than 0.05.
Hey, don't we use that NP hat greater than or equal to 10 for it to be satisfied?
Yeah, that's what I was thinking.
Let's do some subtracting.
Well, if you did the two sample proportion test, it says check the requirements. The first sample is 61.
So then n times p hat, so n, well, that's greater than.
You know what? This time next month, we're going to be done. We won't have to worry about this ever again.
I know, that'll be my birthday present. My birthday's next month.
No, happy birthday.
It'll be my birthday present.
That's a good present right there.
Well, so far all the tests are satisfied. All the questions are satisfied.
I thought we were just basing this off the p-value, which if it's greater than 0.05, we'd fail to reject the HO, right?
It's the 10. Because we're doing the proportion, so I have to do the n times p hat is greater than or equal to 10.
Mm-hmm.
And then n times 1 minus p hat, which is greater than or equal to 10. And doing that, it says the requirements are satisfied.
Oh, I gotta write down that one, because that's the one I kept botching me up. I got it right on the quiz, though, the homework quiz. I wrote that down so many times so I wouldn't forget.
So in the two sample z-test for proportions up on top, see that box that says check requirements, all greater to or equal to 10?
Yep.
Maybe that's why I thought that this was a greater to. Plus everything in first sample is greater to the second sample. So I'm not sure. Okay, so the null hypothesis is P1 equals P2. We know that.
Where are we at now? Sorry.
We're at 21.
Oh, we're still there. Okay.
What number? How did I get so far behind everybody? Because I just did 22 and 23. I thought we were up on number 21.
Oh, so what are we doing for, I thought you were still looking at, to see if it was,
On 21.
yeah. What did you do for 20? Did you do the equal to or not equal to?
On 20?
Mhm.
20 was what was the 20 was the p-value of the test is.
Right, but did you do greater than or equal to or
I did equal.
not equal to?
Equal or not equal.
Equal, not equal?
Correct. Either way, our answer is going to be, if you base it on 0.05, we're greater your answer or my answer, so we would still fail to reject.
Okay.
So I said failed to reject, and then, I'm sorry, I thought, did we move on to 22? What number is everyone else on?
I thought we were down getting the 22.
You guys putting all the information in.
Hang on.
You guys using the chi?
Yeah,
So null is H-O, H-A.
HA, no,
Oh.
null is HO, alternative is HA.
H-A, okay.
This is
Okay,
that
now we're
independent,
doing,
not independent.
let's see, for 22. I used the chi-square test on this, and I got 6.580.
I have 6.579.
That's
So
what I have.
0.579.
Right, so 6.580, or, let me
Point-
see,
Now mine says 6.579.
Yeah.
let me get in there.
Right, but we're only gonna go 3, right? So it'd be 6.579.
Yes.
And then the p-value is 0.087.
Yes.
Wait a second. I didn't do that. Okay, so 6.579, right?
Correct.
And then p-value is 0.087.
Yes.
Okay.
Now the words.
Another day. All right, so p-value is greater than 0.05, right?
This is independent or not independent? Are they independent factors or not?
They
Since it's
are
greater than
independent.
0.05.
They are independent. So I thought that it's no, the p-value is greater than 0.05.
Right. Like that we don't,
That's what I have.
that we
Okay,
don't reject it.
okay. So what do we conclude?
Ah,
So yes, I failed to reject the HO. Wait, let's see.
We have sufficient evidence to say that being a morning or evening person is independent of age.
number 3.
Let me see. That was number 2.
That was number
No,
2.
that was number 2. So we have sufficient evidence.
It's greater than the 0.05.
Yeah.
I know, I have to look every single time.
Okay, so we have greater, our P, it's greater than 0.05.
Mm-hmm.
So that's saying that they are not,
So we
they are independent.
reject it then. No, we failed to reject
We
it.
fail to reject it if it's larger than. We fail to reject it. There's not a lot of evidence.
So if we fail to reject it, do we have sufficient or insufficient
So we're
evidence?
saying, so the null, if we have
And-
the null it means independent. If we have the alternate means not independent. So we're saying that these two are independent of each other. So the only question is do we use the word sufficient or insufficient?
Right.
There is insufficient evidence.
If the null is greater than alpha. So it would be 3.
The p-value isn't less than 0.05.
It's greater than 0.05.
It's
Right,
greater.
so then we have sufficient evidence.
Yes. So we are saying that they are independent of each other. There are
Right.
plenty of evidence to state that they are independent, correct?
Mhm. Right.
So it's 2.
I think it's, yep.
So you think it's no, young people,
So I'm not sure where I got this, but I have this written down. Says reject the null, HO, we have sufficient evidence. Don't reject HO, insufficient evidence.
Correct.
So we have sufficient.
I thought we did not have enough evidence because the value
Because
is
we failed to
larger. We did
reject.
not have enough evidence.
But where we have it's greater than 0.05, isn't that more than enough evidence to say
Have
there?
less, the lesser the number, the greater the evidence. The higher the number, the less evidence.
Yeah, because we failed to reject the null, didn't we?
We should have failed to reject the null.
Right.
So when we
Which-
fail to reject, we have insufficient evidence, right?
Right.
Correct.
So you think it's 3?
Yeah. I think I got this. I went through the PowerPoints that went with different tests. And I think I got that off of one of those.
Okay. Okay. Do you guys want to go on?
Oh, that's funny. Now we have to pick. So we said, yes, the p-value is less than 0.05. And then we said,
We said no, the p-value is greater.
oh, it's greater than point. Sorry, I clicked the wrong one. Good thing I said that. And then we said, we have insufficient evidence.
Okay,
I'll
so
say that more.
this next one we have a
Person.
percent, so we know it's a proportion.
Did you do C or D?
C?
C,
B?
Cat.
Or,
C.
sorry, boy or bat?
C for cat.
C for cat. I was
For
totally. I'll get the wax out. After all that talking, I just didn't mark it. Okay, we're moving on.
Okay, so for this one, I used a one sample Z test, one proportion, and I got 0.190 and 0.310. Let me get in there.
So which numbers did you use?
I used 50 and 200. For one sample Z test for one proportion.
Did you do less than or equal?
This one I got, and you know what? I don't know because it didn't ask for a p-value on this. It didn't ask me for a p-value, I don't think. Oh, yes, it did.
What do you put in for the null? Is it just a standard number or?
I know
Or is
that's,
it that 20%, the 0.20?
Oh, I see.
where did you get that from?
Well, it has that percentage.
Oh, the
point-
20.
20%.
Okay.
So that's why I was wondering if that was the null. And are we doing less than, equal to, not equal to?
I put not equal to because it's a two-sided test.
Okay, I'm totally lost.
All right, where are you at, Cheryl?
So you said you used a one sample t-test?
Portion. Z test.
And I put X is 50 and is 200.
Hold on, I'm in the wrong test. That's the problem. I pulled up all these things, but I pulled up the wrong one. It's gonna be on this one. Two proportion. You did a one proportion. So N is 200.
Mm-hmm.
And X is 50.
Yeah.
And a confidence of 0.95 and a null hypothesis of 20.2.
Mm-hmm.
And what are we trying to find out? If it's better.
So your lower bound should be 0.190. Upper bound should be 0.310. Did everybody get that?
I did get that.
All right, 28.
Oh, I had notes. We just did that recently. What the sample size needed, the formula.
Okay, so
Estimated sample size.
I had a question on this. So I think that N equals 1.96 because we have a 95% confidence interval, right?
Right.
Times the square root of 0.2 times 0.8.
Hmm?
Let me see why I got 0.8.
Because I'm looking at a margin of error being z times the square root of p parentheses 1 minus p over n.
And I have, I got a couple formulas. For solving for N equals Z star, which is our confidence one, for 95 is 1.96, right? Divided by M, which is the margin of error, 2%, 0.02. And that was squared. And then besides that, I have P parentheses 1 minus P.
So that's the sample size. Okay.
I have problems with this one. How do you guys put this in your phone?
One section at a time.
So I just did 0.196 divided by 0.02, which is 98, and then square it. Ends up with some godly number of 9,604, 9,604.
And then
Yes.
divided 0.02.
So the one I did is that margin of error is, so in the square root did p, so 0.2, let me see.
Because you do the margin of error and then the.
Yes, that one right there. That's the one. It's
Oh,
margin of
hold on.
error.
I got my thing on top of it.
Oh, okay, that's not what I. So P.
Because it's just,
I was
that's how you
doing
get
the
that.
bottom one, this second in the middle.
So it's P
Which one?
equals. I gotta write that down.
That's for n. That's where you're trying to get n. The second one is the number, and you already have the number, so we need m, and that's the margin of error.
So we don't have the number yet. So n equals,
We do have n. N's at 200.
but we're trying to find,
You have to
M.
get the margin of error so that
we're
you
trying to
can
find the sample size, aren't we?
Yeah, but you have to do the margin of error to do the sample size estimate equation.
Okay, let me write that down. And then n equals z star margin of error.
I already have n because n is at 200.
Okay, got it. Thank you. So this would be 1.96, and then P was 0.0,
No, just 0.2.
0.2 rather. Times 1 minus 0.2, which is 0.8. That's how I got the 0.8. Okay, so I have the right formula because the
What else
number
did you get?
is,
How would you get?
did you get the number as did you get the number as 0.02?
I have 0.0554.
That's what I
I
have.
got 0.0554.
How did you get
Yes.
the number for the margin of error? What number did you use for that first formula?
So I did 1.96 times
Right.
the square root of 0.2 in parentheses 1 minus 0.2 over n, and you square root that.
Right, so what is n?
200.
Okay, that's what I did wrong. That's what I did wrong. So is it 1536.64?
No.
For what?
Oh, I think I'm doing this wrong.
So on your phone, you should just do the p times, in parentheses, 1 minus p, close the parenthesis, and then get your answer.
I got that, and then divide it by 200,
Yes.
and then you square it. Is that the
Yes.
2 with a little square X on it?
No, it's the house. The check mark looking. It's like a check
Yeah.
mark.
Let me
That's
show
what you use.
Oh, you can't see it.
You know
Okay.
what? I think we still did this question wrong. Because we know that the margin of error or the sample was 200, but it says suppose that you're changing the margin of error to 2% with a 95% confidence. What sample size would we need? So it's asking for n.
It's asking for the sample size.
So the first part, it was 200, but they're saying, I know it was 200, but now we're asking you to change it. So for a 2% error, what should n be to get it to a 2%?
Margin of error.
Right.
It should be the other formula, the n
Well, we
equals,
wouldn't do the m, just the.
now I erased my formula. It's the second one that you held up. It was the one in the middle.
So we skip the margin of error one and just do the other one?
We need
And
N
do
equals
2% as our,
P squared over M, and then squared, and then P minus 1. What was it? P. I need the formula.
1 minus P.
P parentheses 1 minus P. That's what it is. And that should
so
give us
it's
our
2%
number.
as our
that
margin
we-
of error, yeah?
So what margin of error are we going to use?
The 0.02, because that's what it's asking for, a 2% margin of error. So 0.02.
No, 0.2.
No, 2%
Oh,
is
2.
0.02.
The margin error is 0.02, the P is 2.
That's right. That's why I was confused.
So
I'm
it'd be
just not doing this right on my phone. I think I have everything. I'm just not getting it. And then you have to square everything, right? Or am I wrong?
well, you're
Not
gonna
everything.
the first part, 0.196 divided by 0.02, and that's gonna be squared, not square rooted, just squared.
So it's 1.400.
I got 9,604.
How
That's
did
what I
you
have.
get that? How did, no, I am not getting that. I always struggle with this.
So 1.96 divided by 0.02, and then the
Yeah.
x2, you're gonna, so equal, and then x2.
Okay, hang on. I'm not doing it on my phone. Maybe that's the problem. 0.96 divided by 0.02. And it's x2. I get 0.0004. I don't know what I'm
So
doing
break
wrong.
it down simpler. Just do the 1.96 divided by 0.02 and then
Yeah.
square it. The x2, square it.
Oh, 2,304.
Okay, then you're going to, well, I still got 9604.
Let me see. And then you do P.
Because I have 98 is the number, and that's squared, which is 9,604.
But that wasn't one of the options in the
We haven't finished.
exam review question.
We haven't finished. Now you have to times that by P parentheses 1 minus P.
Right.
Which is 0.16.
So 1537, right?
Yeah, that's what I thought.
Yeah, that's the final answer, 1537.
Yep.
All right.
Okay.
Forever
Suppose you
long.
wish to see if there was evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test. Use a level of significance of 0.05. So suppose you wish to see the evidence the top 10 performs better than other investment managers.
So it's greater than, right?
So we're going to have a
I was gonna
greater
say,
than.
So it's the fourth one down?
yeah,
The fourth one?
the fifth one.
Fifth one down? No, because the
Fifth one.
null hypothesis is always equal.
Right. So it'd be
Right.
The fourth one down, the second one is equal, not.
HO is equal, HA is greater than.
Right.
Oh,
Right? So it would be,
wait, it would be the second. We're asking if,
Because it wants to know if
if it's
they
performing,
perform better
Better
performing
than,
better.
which is
Who's
greater-
performing better?
The top 10 business programs performs better than other investment managers. They want to know if the graduates of the top 10 business programs perform better than other investment managers. And they either perform the same or they perform better than, which is greater than.
1, 2, 3. Oh, it's the fifth one down. Sorry, I couldn't see the whole thing. It's the fifth one down, right?
This one.
Okay.
Oh, here's our wonderful, what requirements must be met to ensure that PHAT is normally distributed?
NP
Oh.
greater than or equal to 10.
Yep.
Or is it N's greater than or equal to 5?
I thought it was 10.
That's what I thought.
It's the chi thing, I think,
Oh.
that's greater than 5, right?
Oh, or how about if it's greater than 30, greater than or equal to 30?
We haven't done that one in this.
We
Yeah.
haven't, have we?
No.
So is it 10 or is it 5?
It's 5 if it's a chi test. Well, if it's a chi test, the expected count must be greater than or equal to 5.
Right.
But I don't think we.
But for P hat to be distributed normally,
I think it's
the two
10.
equations.
Because those are the hypotheses for the unproportion.
So is it greater than 30?
No, we haven't used that. That's what we use for the quantitative data.
Yeah.
So then it would have to be 1. The NP is greater or less than 10, what we were just doing.
Yeah.
Okay, test statistic. .768.
I guess I got to pull that back up.
Yeah, 1.768.
1.768 and 0.077.
Where was the black one? You said it's in the dirt post?
Yep.
Ready?
1.768
Gentle.
and what did you have as your p-value?
0.077.
Oh, there, I hadn't changed my,
And then we fail to reject the null because P is greater than 0.05, right?
Yeah.
I just realized I didn't change it to greater than, so the p-value changed.
right, if it's greater than, it's 0.039.
Means we'd.
Because it's less than 0.05 now.
Yeah. So we'd reject the null.
So the p-value is not 0.077.
No. Because you have to
No.
change it to the greater.
Because we wanted greater than, right?
Let me see. 1.768.
And then we failed to reject.
Oh, I thought
We'd reject.
thought we rejected it. You reject it.
So we're not, this isn't a, oh crap. I'm almost up here.
Have to look at that again.
So so for the p-value, is it 0.039?
Yes. So for 33, you're saying yes? I rejected the HO.
Yeah.
Is it yes or no?
Yes, we reject it.
Okay.
Okay, so it's the new information. Which formulas are we going to use? Which Excel sheet?
One sample t-test for means quantitative inference procedures is what I used.
Still waiting for mine to open.
Oh, I had it down at the bottom open. I just clicked it again. Now I gotta open it again.
Oh yeah, there's only one set of data.
Mm-hmm. And my Excel just crashed. Awesome. Nothing's responding.
So you just used a one sample t-test. Crank in.
Mm-hmm.
Mhm.
No, not the one sample t-test. I went to the quant.
The which one?
The inference. Let me see. I went to the one sample t-test for means in the quant inference.
Yeah, quantitative inference.
Right. Okay.
Oh, that's where I was. I just deleted.
I thought you were talking about the other.
I think that's where I was. I think there's the only place that you can put it.
Yeah.
Yeah,
Is it-
it doesn't fit anywhere else.
In the quantitative.
Yes, Caleb.
Where is the rest of my information?
So the lower bound is 0.282.
Yeah, ask Caleb to give it to me.
Oh, I remember this doesn't give you the, I'm like, why don't I have the statistics summary? Because this does not give you that. What is the null hypothesis? Hang on, 95% confident.
What number is our null hypothesis?
I'm reading the problem. Sample of 100. Why does it say there's 200? Of 100 blocks.
How do you determine what the null is?
I know, I don't know. And I don't know if it's greater than or differs from the mean. So it's not equal to, right?
Okay, wait, which test are we? Is sigma known or not known?
The mean population score is 0.295.
Sigma's known.
So then confidence interval. Null is mu is equal to the number, or mu is not equal to, less than, or greater than the number.
Right.
So the null hypothesis would be greater or less than 0.295.
But what do we put in the spreadsheet? And maybe we don't even need that because it's asking us for,
288.
it's asking us for the lower bound, which is 0.282. Do you guys have that regardless of what you put in there?
Yeah.
Yes.
Yes.
That's all it's
Then
asking.
0.293.
And then 0.293
And then degrees of freedom.
is 99, right?
Yeah.
99.
And the
Statistic.
statistic I have is huge. It's minus 3,683.938.
That's what I have.
I have negative, I changed the null hypothesis because I thought that was the mu. And I have negative 2.803.
What did you change the null hypothesis to?
I thought that when she read that, the null hypothesis said that it was the mean, right?
Well, the mean is 0.288.
If you go to
It
the
says,
information above 30.
no, it says in the printout, it says these scores are recorded in the data file. He wants to use this data to see his mean blue score differs from the mean blue score of another leading translator software, which has a population mean score of 0.295.
Yeah, above 36 it says it. It has the HO, the mean and the, you see that?
Mm-hmm.
So it has that in there above 36.
But what did you put for the null hypothesis in the spreadsheet?
I put
0.295.
that 0.9295.
So the confidence interval is 0.295?
For the null hypothesis?
Uh-huh.
Yeah,
0.295?
yeah.
Oh, it doesn't like something I did. It just put an error. I think I put a point after my 99.
So it's minus 2.803 then.
Yeah, that makes a lot
Yeah.
more sense. Good
Mhm.
catch, Cheryl.
And that's point, sorry, I put 99 point and it says, you made an error, and it pitched me all the way to the very top where we started. So now I'm having to scroll back and hopefully not screwing up any of my answers. So it's just
And
99 on the degree of freedom.
Is it not equal to then?
Yeah, not equal to.
So the
Wait,
p-value
what'd you
is
get for 38?
0.006?
38?
Yeah.
Oh, I haven't got there. Hang on. I had to fix my oops.
Because I have p-value.
0.00609.
Yeah, 0.006.
Can we
Because
do
you changed it to not equal to?
Right. Is that right?
Is it not equal?
Yes, because it says HO was equal to or not equal to. So not equal to would make our p-value 0.006.
Do we have sufficient or insufficient? Let's start there.
Well, it's small. We have less than, so we reject the null hypothesis. So we have
Sufficient.
we have sufficient evidence against the null. So the null was, it's equal to, so we have significant that it's not equal to.
But it's asking,
For the true
I
mean.
mean, it's different.
if the true mean is different, equal to, so we have
That's all I
insufficient
have.
evidence
I think we won.
that the true mean is different than 0.295, right?
Yeah.
Right.
When are we going to use this?
Never.
If you write some fancy paper and get
I'll pay
published, you
someone
might
to
do
do it for me.
that.
I have to do this.
Delegation
Define
is an
enough to
awesome
write a
tool. I love
fancy-
delegation. Okay. We have one more?
Yeah.
Oh,
Yep.
Yeah.
what the heck?
One more. We
We
got
have
the,
like 10 more questions. 6 more
yeah,
questions.
but they're all gonna be pretty,
Are you
Okay,
trying to
we
give
need
us more
8.
work?
Sorry.
load. Ugh. It says I've already got it open somewhere, so it's not letting me
Okay.
have it. Okay, AM. So we have AM and PM.
Yep, I did input in pairs sample t-test for means.
Did you say paired or two test?
Paired. Because it matters because you're doing the same person to see if they're bigger or smaller.
Yeah, you're getting the difference.
Yep,
True mean difference of heights.
right. Okay, I'm good.
All right.
So how many do
We
you
have
have
41
for?
and 41.
Yeah, 41.
So
And then
degrees
we're
of
all
freedom
like-
is 40.
Okay. Scroll
So the
down.
lower bound is 8.725, 28 rather.
I have 2.8.
Yeah, 8.728.
I gotta move it over so I can see it. Lower bound, 8.728.
And then
Upper
10.5.
bound, 10.455. Now, did it say which one to make?
And the test statistic, okay, so not equal to, right? Or is it, let me see.
Now, do we have a null? That's
No.
it, right?
I got,
Yeah, we weren't given a number.
so that's
And
0.
not equal to? Are we doing not equal to?
Well, they want to know if they're taller in the morning, so is it greater than?
Because
It
The
won't
question
change the
is-
test
Oh, that
statistic.
doesn't, yeah, no, it doesn't.
You want to determine if the children are taller in the morning than in the evening.
But the test statistic is still 22.446,
yeah.
right?
Yes.
The only thing it changes is the p-value.
The only thing, the only thing that changes is the P.
And then the degrees of freedom is 40.
20.
Okay, here's the p-value. There you go.
So
I'm
they're
gonna
asking
do-
if they're taller, right?
Yeah.
What did you say,
So it have to
Sarah?
be greater than.
Yeah.
Gotta be greater than, and I get 1.39734 E minus 24.
Three
So
decimal.
397.
think we're on our last question. Da, da, da.
We are.
P-value is huge. So we failed to reject the null. But is it no, we failed to reject the null, or yes, we failed to reject the null?
Just lost something.
If it's large, we fail to reject the null.
But is it yes or no?
What was the null?
I was gonna say, what was the null? Let's go back up.
It's still
Yes.
not going to be over 1. It's typically less than 1. P is greater than alpha,
So they're saying that you are taller in the morning
so it's
than
yes.
when you go to bed.
So it's yes because we rejected, because we failed to reject the null. What did you guys get for that? The last one?
Yes, because we failed to reject the null.
Is it yes then?
Five.
What's that?
We missed number 5.
We missed number 5?
Yep.
It's not an independent sample t-test?
The student project compared the effectiveness of 2 different combination locks. So we have 2 different locks. One of the locks turned clockwise, the other turned counterclockwise. Now we're using the same 25 students, and they're just testing 2 different locks.
Maybe it was the paired samples?
No, that doesn't, maybe it's just 2 proportions. Because they're not, are they paired?
The only thing they have in common is the student
Yeah.
that's using them. They're 2 different locks.
To each lock and asked to open the locks. Oh, then it is based on the student, so it would have to be paired.
Because it's the same students on how they,
They want to determine if one lock is easier to open. But don't they compare the times for the same student, right?
Yeah.
So, Lydia, I haven't submitted to mine yet. Is question 11 95% of all 95% confidence intervals actually contain the true mean?
Nope.
It's not. Is it the last one?
It's not the last one. There's a 95% chance that the true mean is between 10 and 20. It's
Yeah.
not correct.
Oh, that's not correct?
Nope.
Which one's
So-
not correct?
11,
11?
Which one did you put, Lydia?
the 4th one.
The 4th one?
So I put the second one on that one. Did we miss any more?
Yep.
A lot of them?
I don't know yet.
Oh,
Question 15.
Yep.
I had 0.013.
Yeah,
Correct. That's wrong.
it's wrong.
That's wrong.
So that was the one that I thought we took the 2 and divided it by 2.
Or I thought it was p hat 1 minus p hat
Right.
2. Oh, lower and upper bound. It wasn't p hat, it was the confidence interval.
Divided by 2, whatever the confidence was for that.
Right now I have to go put those numbers back in.
Well, I'm definitely not going to do well on this test.
We
Oh, I'm
missed.
so dreading. I'm going to take it on Wednesday. It goes till Wednesday till midnight, right?
Yeah. We missed 44.
$1.397 was wrong.
Yeah.
What did I do with my paper?
Lydia, did you get 45 right?
No,
Neither did I. What'd you put?
the fourth one.
I put the first one.
So then we have to reject it, not fail to reject it.
Yeah.
Yeah.
Oh my gosh.
Is it yes or no?
I know. This is not good. Did you get the last one right?
No.
No, we both got it wrong. So it's not 1 or 4.
I have 3. But I haven't. Oh. Let's see.
It's not 0.013, because the confidence interval, what margin of error is a 95% confidence? If you take the upper and the lower and divide it by 2, we get the same answer that we came up with p hat minus.
No, it's not the p hat though. It's the confidence interval.
I know, but the confidence interval of 0.029 minus 0.003 is 0.026 divided by 2 is 0.013. And p hat 2 minus p hat 1 equals 0.013. Oh, it's negative 0.013.
Negative?
It's negative, because if you take 0.026 and minus 0.039, it's negative .013. I don't know which other one I got. I guess I'll submit this and see where I am. Do we have 2 attempts at this or only 1?
I think we have
Two.
2.
I missed number 9.
Yes. I had the third one.
2.
I put the second one. Type 1
Yeah.
error.
I put the second one. It's right.
For which one?
For number 9.
The one we questioned. I missed number 15 still, even with negative. So 15 is still wrong.
What'd you put for 45? And did you change 44?
Hang on, I'm going down still. I missed 21 as well.
Yes.
I put
I
number
put D.
4. Me too.
Yeah, same one.
Yeah, I told you guys wrong. Oh, wait. Number 21?
Yes.
I got it right. I did the last one. What'd you guys do?
D.
D.
I got number 25 wrong.
I got the first one on 21. What did you get, Lo?
I did no, I failed to reject HO, the last one.
Oh,
What'd you get for 25?
I
The
put
last
C
one.
and it's wrong.
I put the last one and it's right.
And I got 44 wrong. I put 1.397.
Yeah, that's what I put also.
And I got 45 right. It's C.
44 is 1.397, which is wrong.
Right. So we must have picked the wrong what it needs. So let me go back up. Oh, this is a lot of questions to
The AM, PM.
enter.
I think I'm gonna take off.
Okay,
I'm tired.
good luck.
Yeah,
What'd
you
you guys get? What'd you get for 11?
Hold on.
Because I got the. I
I'm
picked the fourth one.
scrolling there.
11 I got wrong. I did the fourth one because I told you guys wrong apparently.
Hold on, I'll be there. 11 is
I think it's,
95% of all 95 confidence.
that's what I thought.
Esther was right. I'm sorry.
That's okay. I'm still trying to figure out that other one, the 1.3.
I know, 15. And I
Number
need 44. What was 44? Oh, 15 and 44.
I don't know what 44 is.
I don't know what 15 is either.
15, let's see.
All right, well, you guys have a good night and good luck on your
Good
test.
night. Good luck on your test. Happy Thanksgiving.
You too.
Thank you. Bye.
Bye.
Oh dear, this is not
Where'd you-
looking good.
5.
For which one?
5.
5 is paired sample t-test.
Yep.
I'm going through and writing down my answers. Hopefully I transfer them correctly.
And 6 is paired samples t-confidence interval, right? That's about when my computer was going down.
Well, I just put C, so whatever the third one is.
Yep, it is.
All right, I'm gonna get it off, guys.
Okay, have a great night. Happy
Thanks.
Thanksgiving.
Yeah, happy Thanksgiving.
You guys have a great one. Hope we get this 15 and 44 figured out.
Yep. Good luck. Good luck on the test.
You too.
See you Tuesday.
Good night. I am confident 7 is the last.
I'm going to put this other one again for AMPN Heights.
Well, I'm just writing down the answers so I can transfer them.
Don't we have to do something else for that p-value?
I'm going to think about it in just a second. Let me finish writing these down and all.
Okay.
Because just as soon as I don't, you know what, I bet I can open this test again. And then just mark them one to the other instead of writing them all down and doing it wrong. Let me see if I can do that really quick. Since I submit it, see if it'll let me open it. Excuse me.
Bless you.
Thank you. Oh, heck. Group meeting quiz. Oh. This is what I should have done all along.
Which is?
I can open up the quiz that we just took and open up the new quiz. So I can just click and then have them side by side.
Oh, I didn't know you could do that.
Yeah, I just figured out how to take like I have 3 screens open. If I click on the one at the top and I slide it over while I'm holding it, it'll take it out of there. So now I have both the screens one beside each other. I just figured out how to do that. Come on, I want to make that one a little smaller. There we go.
Okay, the margin of error. That's the one.
Okay, so 9 was B.
I'm seeing what we did wrong in 15.
So 15 is wrong, 16.
We got 16 and 17 right?
Correct.
So how could we not get the margin of error right? Oh, because we have to do a calculation. Okay,
We did.
what did we do wrong?
That's what I don't know. Because I thought it was the upper bound minus the lower bound divided by 2. Which is the same as p hat 2 minus p hat 1.
Well, let's see. That was not one of the exam review questions. I don't know what. Oh.
Sorry, it takes forever to go through and mark all these.
It shouldn't take 3 hours to do a test. This is
Well, it
ridiculous.
says it's going to take 2 hours. It says right on the thing 2 hours.
Yeah, but
If it takes 2 hours for us to do it all together, I can't imagine doing it in 4 hours alone.
dang it. All right, let me get back to my. Oh, you know what? Maybe we have to add them, Cheryl, Because one of those is a negative.
Oh, and a negative and a negative become a positive, but hang on a second, I'm so close to to being there where I can look at it.
Go to 6.
Okay, so 44 was wrong. And
Still trying to find that one that I erased. Oh, 44
so we
p-value. I have no idea. I'm looking at it right now.
put the p-value for this test. So let me, okay, I can look now. I got everything put in other than 15 and 44. So 44, that was, which test were we, excuse me.
That was the one with a mean of 90, or degrees of freedom were 40. Oh, darn it. Hang on. I think I have the wrong one.
So it's not any of those. I got both of them up here. So let me just, okay, that was the paired sample t-test.
Yeah, let me find that. Yeah, degrees of freedom were 40 on that one. And we got all the other questions right.
Right, so this would be then, it would be a matter of the question, the hypothesis, is it greater than, less than, or equal to?
Right.
So that's going to be, so let's reevaluate the question because that's ultimately what it was asking.
They want to know if children are taller in the morning.
So it'd be
than in the
equal or
evening.
not equal? Are they or are they not, right?
Well, they want to know if they're taller in the morning than the evening, so wouldn't it be greater than? Or
Because that's what we did was greater than, so that's not right.
then it might have to be less than, because if you're talking about greater than, if you're talking about height that's greater than, let me see.
No, it's just really,
Is it not equal to?
I'm saying, okay, do you determine if the children are taller in the morning or taller in the evening?
Or taller in the evening.
You want to determine if the children are taller in the morning than in the evening.
Than in the evening. Okay, so it would be greater than in the morning, smaller than at night. And greater than was wrong?
Greater than was incorrect, because that's what we put.
That's right, 1.397.
Define the differences as AM heights minus PM heights. Construct a 95% confidence for the true mean difference of heights and conduct a hypothesis test to determine if the children are taller in the morning than in the evening. So taller in the morning, AM taller than.
Well, if it's less than, it's 1.000. If it's not equal to, it's 2.795. I just don't know.
The data is recorded. You want to determine if the child are taller in the morning than in the evening. So determine if the children are taller in the morning than in the evening. So taller in the morning. So it would be greater in the morning.
We did greater than.
Right?
We could do less than.
Well, I'm just trying to think. Are taller in the morning than in the evening. So what's HO? So just let's think about this for a second. So HO, the hypothesis is the study done to test the notion that people are taller when they first wake up.
Did we put these in the right order? Yeah, we did, because everything else is
And that's
right.
how come everything else is right.
Right.
So the HO is that you're taller in the morning than you are in the evening. Or HO equals taller. Right?
HO, yeah, because the null hypothesis would be not taller.
So that's
No.
what I'm saying. It's equal or not equal.
Let me see. I hate this because I can only see part of a question at a time. It makes me crazy.
People are taller when they first wake up in the morning than in the evening. So if it's not greater than, it's either you are or you're not.
Do you know how to figure the p-value when it's got the -24 or the +24? Do you know what that means?
Well, I did less than, and I got p-value of 1.
1.000, but then it's got e plus 00. What does that mean?
Oh, mine doesn't say that. Oh, because that's saying that the number is so super, super, super long that it won't fit.
Oh. Okay.
So that's if it's less than, the p-value is 1. And if it's not equal to or equal to, it's 0.000000.
So, yeah, I think
I'm
it's
going to put 0.000.
I
I'm going
think
to put not equal.
Yep, I think it's .000.
That's what I'm gonna put for 44. And then back up to number 15. Let's look at 15 again.
So for 15, I got .016. Is that wrong?
That's not what I got to begin with, so hang on. I was just making notes of what I put down.
So what I did, Cheryl, was I added the two together, the confidence intervals, because you've got a negative number there.
Hold on, I gotta find the right, I gotta go back to that particular test.
It's the two proportions.
And it's on the other one, so let me go here and pull this one up. Okay, two proportion, and this was
Minus .003 plus .029 divided by 2.
let me do this again. So it is 0.029 minus 0.003 negative equals 0.032.
And then divided by 2.
By 2 is 0.016.
Right, that's what I put in there.
So I wonder how I got my math wrong on that.
So let's go over all the questions.
Hang on, let me just 0.016. I don't know how we got so whacked out on that. Okay.
Yeah, because we subtracted them, we didn't add them. Because we
Well,
have
I
that.
still subtracted them, but for some reason it must have subtracted because it's 0.029 minus a negative 0.003, which makes it positive 32 divided by 2. But for some reason my calculator must not have done that. And so we got 0.016.
Yeah.
So I'm sure we did the math right. I was so confident on that math. So I must have just did something wrong. Okay, so I'm good. You want
to go over everything? Tell me.
Yeah, just to make sure I typed it in right and you typed it in right.
Yeah. Okay, so let's go to 3.
So start.
4. We know about. Where do you want to start?
Oh, might as well start at the top. So question number 2, we had chi-square or chi or chi or whoever he is. And then we had a test of 2 proportions.
Right.
1 proportion.
Right.
Paired sample test.
T-test. Yep.
And then a paired sample T-confidence.
Yep.
And a confidence interval 2 proportion.
Yep.
One sample T-confidence.
Right.
The probability of a type 1 error.
Right.
The probability of observing a sample statistic more extreme.
Yep.
95 of all 95.
Yep.
0.30.
Right.
0.0458.
0.046 is what I got on that.
Oh, you ran, I didn't, okay. It still took it the way I wrote it, so.
Oh, it did?
Yeah, 0.046
Okay.
is what you put, you submitted?
I haven't submitted yet.
Oh, shoot.
Because I had some X's in here that
Okay.
that I had question marks on, so I haven't submitted it yet, but
okay,
that's how I'm going to write mine. And then for 14 is 0.139.
Hang on. Because I know I got it right with the other answer.
Okay.
I just don't want to change, because every time I change it, I get...
You get dinged?
Yeah. That's why I was trying to make sure I was so specific. So 14.
No, 13.
Which number was that?
13.
13, I put, and I did get it right. I did 0.0458. I don't know why, because I know I usually just go 3 decimals, but it took it. So, okay, so 0.138.
Oh, I had 139 for 14. Did you get that right?
I got it right, 1.138.
Okay.
And then 0.016,
Yep. And then
negative
minus,
0.003.
but you had minus 0.003, right?
Correct.
Okay.
I'm just making sure. And then
17 is 0.029.
0.029. And then the first one,
Oh, for 18 is the first one?
yep,
Okay. And then the value of your test statistic is 1.458.
correct.
P-value is 0.072.
No,
No?
no, 0.145.
For the p-value?
Yeah,
For 20?
20.
Oh,
0.145.
1.458. Is that right?
0.145.
Oh, point. What the heck was I doing? Okay, and then did you get the last one on 21? No?
Correct.
And then 22 is 6.579.
Correct.
23 is 0.087.
Correct.
And then I got the fourth one down, no, the p-value is greater than 0.05.
Correct.
25 is the last one.
Uh-huh.
26 is 0.190.
Correct.
27 is 0.310.
Correct.
And then 1,537 for
Right.
28. And then I got 1, 2, 3, the fifth one down, second one from the bottom.
Right.
And then the first one,
Correct.
1.768,
Yep.
0.039. And
first
then failed to reject. Oh, the first one.
Yes.
And then 0.282,
Uh-huh.
0.293,
Correct.
99, and minus 2.803,
Correct.
0.006,
Correct.
and the third one down. Did you get that one? The third one down?
Sorry, I lost track. For number 39? No, it's the
Mhm.
first one.
It's the first one?
Yeah.
Crap. Okay. And then 8.728,
Yep.
10.455,
Yeah.
22.446, right?
Yep. 22,446.
And then 40, and then 0.000 for the p-value.
That's what we were choosing. Yeah.
And then the third one down for 45. We
Correct.
rejected the null. Save all responses, submit. This was ridiculous, 3 hours.
Yeah. Well, let's see.
We got them. We got them all.
Cool.
Hey, Cheryl. Happy Thanksgiving. Good luck on your quiz, okay?
Oh, you too. Thanks for hanging out and going over that.
Yeah, we'll see you on Tuesday at 8.
Okie dokie. See
All
you then.
right, don't work too hard. See ya.
Bye.